friends, as in our last two classes we were talking of material requirement planning, and we discussed that how we have to do the work much in advance than the due date of delivery of our final product. With the help of one example in our last class, we discussed that the product which we are delivering in the 8th period, we have to work for that from period number 1. When the sub assemblies have started coming, then only you will have the due delivery of that product possible in the 8th period. One very simple condition we took, that if whatever is the requirement, we are going to deliver the same requirement as and when it is possible. But in real life, as we said, that there may be many constraints also. We may not be able to deliver what is needed in a particular time because of different type of cost related constraints, and that is what we are going to discuss in this particular session, that what are the different considerations when we are deciding the size of our order, and this we call as improvements in our MRP system, where we are seeing that different types of lot sizing models are possible. One simple case which we have already discussed in our previous class, that is the lot size of how much order is required, the same order quantity we are delivering. So, in this particular class we are going to discuss that can there be a better policy, of deciding the size of our lot. If I require, let us say, what I want to say, that we discuss in the inventory also, my immediate requirement is let us say 5 units, but it may not be economical to buy just 5 units, and I know that there will be a future requirement also. So, in place of 5, I generally purchase 10 units, 5 for immediate consumption and remaining 5 for the next requirement. So, and in some cases whatever is the requirement, I just purchase that many. So, lot size of the order is a very important issue because of cost related implication, and this is important whether we are talking of independent or dependent demand. In independent, with the help of let us say EOQ, EPQ, optimal order quantity, all these are different type of scenarios we have discussed in our previous many classes. But now we are bringing this lot size issue in case of our dependent demand system also, which we are calling as MRP. Like dependent demand system, because of much wider variety of plant, it is used to have more use of our lot sizing principles. So, the simplest of all the methods of deciding how much should be your order quantity is the lots for lot ordering. So, we are going to give the order of a particular lot as per our requirement. So, in this case the order and the run size for each period are equal to demand for that particular period, and you are giving order of only that much of quantity which is required for a particular period. Obviously, you can easily understand that there will be no inventory holding in this particular case. So, your inventory holding cost is 0 practically for lots for lot ordering. Inventory holding is 0. So, one important, you can say, use case for lots for lot ordering, that those items, those components, sub assemblies which are very expensive to hold, where the holding cost is very high because of some precious nature of those components, it is advisable to go for lots for lot ordering. In case we will show with the help of data also, but qualitatively I will like to say that there may be many items where the holding cost is not so significant. In that case, maybe lots for lot may not be a good idea, but wherever the holding cost is significantly high, you should go for lots for lot ordering system, because it reduces your holding cost to 0 level practically. But there are some limitations also. Some limitations are also there, because it usually involves many different order sizes. Every time your demand is changing and the order quantity will also change, and therefore, you may not be able to get the advantage of economies of fixed order size, because every supplier or every setup may not have that kind of convenience expertise to handle different types of order size. And because your order size may vary from one cycle to another cycle, there may be challenges in fulfilling that requirement, and it may increase the cost. So, whatever benefits you are going to have for reducing the holding cost to 0 level, those benefits to some extent neutralized because of variable order sizes. And another thing is, it may require a new setup for each production run. Every time you are producing, so sometime you are producing for 100 items, another time you are producing for 500 items, another time you are again producing for 100 items. So, this variable product run may again put some kind of pressure on your manufacturing system, but this when you are doing the production of these items in house, because in MRP it is not necessary that all the items which you are which are there in your structure are procured from some outside agency. These may be, all these items are produced in house itself. So, in that case the production run will change from period to period, because you whenever there is a demand, you are going to start the production run. You will never have items in inventory, so that you can fulfill some of the demand from readily available stocks, and that also increases your lead time for delivering the final product, because you never have any item in stock. You need to start the production, and then only you will come to make the final assembly. So, the lot for lot sizing sometime may increase the lead time of delivery of the final product also. Let us see one simple example with the help of this data, where for different weeks the net requirement, you may remember 2-3 important terms: gross requirement, net requirement. And net requirement comes from the gross requirement by subtracting your inventory on hand. But since there is no inventory on hand, so your gross requirement is your net requirement, and that is what, and since we are following LOL, this table is representing LOL, lot for lot. So, in this lot for lot system, you are going to produce the same quantity whatever is your net requirement. So, you can see the column number 2 and 3, they are exactly same, whatever is your requirement, same you are producing, and there will be no inventory holding, because you are consuming the same in the same period. So, the column 4 has only 0 entries, and since there is no inventory holding, so there will be no inventory holding cost. Every time you are running a production cycle, you are doing some kind of a production activity, there is a setup cost. Setup cost is 47 per setup. So, you have to pay every week a setup cost of $47 that you are seeing in column number 6. From period 1 to period 8, every time you are paying $47, and that is our total cost. This is the total cost of this system, which you are incurring $376. So, this is one type of system where the total cost is this much. Now, let us move further, and we will see in this second example that we are going to have a kind of a system which is based on EOQ system, that our annual demand is something, and now if you see the demand for 8 period is given to us, and this 8 periods demand, 8 period demand is used to get annual demand. So, 8 period demand, total 8 period demand is, the sum total is 525, and this 525 is used for getting my annual demand of this particular product, which is coming to be 3412.5 units. The holding cost is at the rate of let us say periodic holding cost is half a percentage of the material price. Material price is 10 rupees and half a percentage, so that is our annual holding cost. The setup cost we already assumed, every time you are doing the setup you are incurring a cost of $47. So, using this information our economic order quantity becomes 351 units. Economic order quantity becomes 351 units. So, meaning of this EOQ is, now whenever we place order, it is of 351 units. In earlier case, you were placing small orders of 50, 60, 70, 60, 95, so on. Now, we will not place these small orders. We will place order of 351 units whenever there is a requirement of placing the order. So, now let us see that how we are going to use this information. So, our EOQ comes out to be 351, EOQ is 351 units. Now, EOQ lot size in week 1 is enough, this is the assumption, to meet requirements for week 1 through week 5 and a part of week 6. Then in week 6 another EOQ lot is planned to meet requirements for week 6 to 8, and here we see that EOQ plan leaves some inventory at the end of week 8, carry forward to the week number 9 also. So, you see this particular table, which is a revised calculation of this particular calculation, where we had LOL on slide number 6, and now if I go to slide number 9, this is calculation for EOQ lot size, and EOQ is equals to 351. Now, in the first week when my requirement is 50, my production quantity is 351, and here I am ending with 301 units. I am ending with 301 units, and 301 units will be hold in my stock, and the weekly holding will come at the rate of let us say half a percent of material cost. So, 0.5 into 10, that is 0.5%. So, it is divided by 100 into 301. So, it becomes somewhere around 15.05, that is what written here, and setup cost is 47. So, the total cost is 62.05. In the second period, now I will consume 60, but you see please here there is no production happening, because you already have 301 units in your stock. 60 minus, you are left with 241, and similarly 0.5 into 10 into 241, your cost is holding 12.05. But this time there is no setup, this time there is no setup because there is no production. So, your 62.05 plus 12.05 gives you the total cost of 74.1 and so on. Now, when you are finally at this level of ending inventory 16 and in the sixth period when you are requiring 75 units, you will do another production of 351 units and out of 351 you have consumed 75, 16 were before you. So, in fact, this is 16 plus 351 minus 75 equals to 292. So, you will pay now holding cost on these 292 which is 14.60. Since a production is happening this time, you are paying a setup cost of 47 and now the total cost is this, and in this way you are going, the total cost is coming 171.05. Here you see that you are paying only 2 times your setup cost which is just $94 and remaining all is your holding cost, and the total cost is coming holding plus setup is 171 which was 376 when you were doing LOL. So, total cost LOL was 376 and total cost using this EOQ formula 171. So, you can easily understand that it gives you huge economical benefit for using this system of EOQ. You are able to substantially reduce your total cost of holding and setup. I hope it is now aptly clear to all of us. Then another type of model which we follow, that is least total cost system. That is, it is a dynamic lot sizing system where we are not following a particular quantity. In our EOQ system, we have followed a particular quantity, that is 351. One more thing I will like to tell you, whether it is LOL or our EOQ system, you are giving the order of this EOQ quantity in the period when the demand is there now, but actually you need to give the order few periods before, because you know the concept of lead time, and because of the lead time it is not possible that the same week when you have the requirement you are producing also in the same week. If I require item in the 6th week, maybe I have to start the production in 3rd or 4th week, then those items will be available. That is what we have already discussed in the MRP. But right now our purpose is to explain you that in how many different ways lot sizing can be done. So, 2 systems of lot sizing we have discussed. Now, going for the third system, that is the least total cost. It is a dynamic lot sizing technique that calculates the order quantity by comparing the carrying cost for various lot sizes and then selects the lots which are nearly equals. And then another type of lot sizing system is least unit cost. Now, it is also a dynamic lot sizing technique, but here we are calculating the cost for the entire lot and here we are calculating the cost for each unit of the lot. It is a dynamic lot sizing technique that adds ordering and inventory carrying cost for each trial lot size of method 3 and divides by the number of units in each lot size and picking the lot size with lowest unit cost. So, that is the difference between third and fourth. In one case you are comparing the lot size for the entire lot and in another you are comparing for the unit cost. So, let us see the example with this system when we are seeing the least total cost system, and in this case the quantity order, the data is same what we have seen in the previous class 50, 60, 70. For the sake of convenience, let me take the data 50, 60, 70, 60, 50, 60, 70, 60, 50, 60, 70, 60. These are the 4 weeks data. Let me add 5th week data also, 95, 75, 60, 55, 95 also. So, like if I am considering only week 1, it is 50, week 1 and 2 110, 50 plus 60, week 3 50 plus 60 plus 70, and week 1 to 4 50 plus 60 plus 70 plus 60, and then if we want to have up to week 1 to 5, 50 plus 60 plus 70 plus 60 plus 95, and then if I want to add more data, this is 50 plus 60 plus 70 plus 60 plus 95 plus 75, etc. So, in this way your ordered quantity is changing from 50 to 110 to 180. These are different possible lots, you can say possible lots. The carrying cost and the ordering cost, if it is 47, 47, every whatever is your lot size, that is the 47. Now, carrying cost will depend that how many items you are going to carry for one period, because if you are ordering only of 50, all 50 you are going to consume in one cycle. So, there is no carrying cost, but if you are ordering 50 plus 60 in period 1, then what happens, 60 is the ending inventory and you are paying at the rate of 0.5%, 0.5 into 60 into 10 by 100. So, you get 3 rupees as your inventory carrying cost in this case. Similarly, if you are keeping 180, so in this case 50 plus 60 plus 70. So, here you are keeping 60 plus 70 for 2 periods and 70 for 1 period. So, in fact, it is 50 plus 60 plus 70, 130 into 10 into 0.5 by 100, that is 6.5, and 70 into 10 into 0.5 by 100, 3.5. So, total holding cost becomes 10, that is here, and in this order you are keeping the holding cost for all these possibilities from 1 to 8, and then you are keeping the ordering cost also. Now, out of that you are doing the total of carrying and ordering cost, and you see that out of all these common, the 66 is the cost which is coming here. This is placing the first order. So, we see that how these total cost calculations are done, and the important thing we need to see that as our carrying cost is increasing over increasing the number of our lot size, the total cost is also increasing. Now, we need to select a total cost where, if you go back to our EOQ calculations, where carrying cost and ordering cost are nearly equal, and when carrying cost and ordering cost are nearly equal, let us say nearly, if you see the lowest total cost is 47, but here the difference between ordering cost and carrying cost is very huge, 47 units. In the second instance, the total cost is 50 and the difference has slightly reduced, it is 44. Further the difference has reduced, it is 37, and further the difference has reduced, it is 39, and then you increase the ordering cost carrying cost further, and now the difference is just 9 units. $9 difference. So, this becomes our point of placing the order, that is 335, because if you go further beyond this point, the difference has started increasing further. It is 9.75, and then subsequently the difference is further increasing. So, the lowest difference between carrying cost and ordering cost is at the level of 335. So, we get this order quantity for our week number 1. After this 30, then this lot of you see in this table, which is a clean table, the initially I will place the order of 335, and in this way I have developed the calculations for my inventory. Now, in the second round, we need to see this calculation again, that the inventory is fulfilling the requirement up to period number 5. Again you start that what should be your order quantity for different kind of combinations. Then you see you are doing for week number only 6. In fact, this is 6, 6 to 7, 6 to 8, and like that. You have to see that what should be my second order quantity, and there may be possibility of 75, 75 plus 60, and then like that. And here the difference is minimum in this particular case, though it is a huge difference, and it is possible to do much better calculation if I have data for more subsequent periods, then I will have a bigger lot size. But considering the limitation of data at the moment, I have the second order quantity as 190, and here you see my total cost is coming 140.50. So, in this case we are able to see that our lot size LOL, then our total cost was coming around 376. When our lot size was EOQ, our total cost was coming 171 around, and now we have this least cost, it is 140.50. In a way, this is how analytics play the role, that you are improving. These are alternative options available in front of you, that you can go with LOL, you can go with EOQ, you can go with least cost, and you see that out of these three, least cost is the most profitable, or reducing the total cost of inventory of your MRP system. So, with this we like to conclude, and we leave one question unanswered for you as part of your homework, where you do this least unit cost calculation. See that whether, and let me tell you, there is no hard and fast rule that every time EOQ is going to be inferior to least cost, and every time LOL is going to be inferior of all these. It depends upon relative values of holding cost and ordering cost. For example, if ordering cost is very low, in that case maybe LOL system may also work very well, because every time you are placing the order, holding cost is very negligible, 0, and the setup cost, ordering cost is also low. So, in that case our LOL may also go in a better way. So, it is all possible on relative holding cost and ordering cost terms, that which method is useful. So, we cannot conclusively say that LOL is always going to be inferior. Yes, LOL is the most important and the best way whenever you have very high holding cost, because it actually reduces the component of holding cost to 0 in LOL method. So, with this we come to end of this particular session, where we discuss that in how many different ways lot sizing decisions can be taken in our MRP system. And with this we will now start our discussions on how we are going to optimize revenue in a constrained environment from our next class onwards. Thank you very much.